So, is hyper-converged the only way to the software-defined data center? I think this is really an interesting question, and I'm happy to be here on the stage to do together with you this reality check of hyper-converged infrastructures. You know, there is so much noise and so much talk out there about digitalization here at the event and out there in the market. So I do not want to stress this topic too much because everybody is doing it. But let me make one statement. In the digital age, we are faced with an ever-increasing amount of data. And this data needs to be collected, it needs to be transported through the networks, it needs to be processed and analyzed, and it needs to be stored. And this has, of course, a huge impact on data center infrastructures, on the servers, on the network, and on storage. And from a customer's perspective, the needs are crystal clear. You know, as the data is ever increasing, scalability needs to be fast and flexible. On the other hand, resilience is key because infrastructures need to run 24 hours a day. And of course, they should be managed in a simple and in an efficient manner. And if you compare this with traditional data center infrastructures, which are admittedly hardware defined and therefore rigid, where management happens in silos, where you need dedicated teams for the compute resources, for the storage resources, and for the network resources, where certainly there may be a certain level of automation, but most of the things still need to be done manually during operation. And this means, of course, things are very slow. So in a nutshell, a traditional data center infrastructure is complex, it's inflexible, it's expensive, and it requires really great skills inside the IT department. And the exciting question is now, how can we change the game? And there is certainly not only a single answer to this question, but one of the answers is hyper-convergence, hyper-converged infrastructure. And there is so much noise in the market, and sometimes I got the impression that not everybody has the same understanding what hyper-converged infrastructure means. And just to make sure that we are all on the same page, I want to briefly summarize the main characteristics of hyper-converged. So first of all, we understand by hyper-converged it's an interconnected, or it's standard servers which are interconnected, where we don't have an external storage, where storage spreads across the local disks of the servers in that cluster, where we do not have a physical storage area network, where we have a virtual one instead, which spreads across these local disks of the cluster servers, where data services are integrated, such as data replication, deduplication, compression, snapshots, data tiering, whatever you know from external storage systems. And actually, as a consequence, high availability is built in, because whenever one of these servers fails, there is still another one that can run the workload of the failed server, and data will not be lost due to the feature of data replication. On the other hand, there is a unified central management for both compute resources and storage resources. And the absolutely great thing is the ease of scalability, be it in terms of performance, be it in terms of storage capacity. Whenever storage capacity or compute performance is scarce, then you just add a server or a couple of servers. These servers will be automatically discovered, and the integration with the existing cluster will be very, very easy because everything is software defined. And resulting from these characteristics, basically, we can derive a lot of benefits. As we have no external storage, there are less components involved. These less components require less space in the data center. Energy consumption is lowered. Cooling requirements are reduced. As we said already, the administration efforts can be reduced. Everything becomes simpler because storage and compute is more or less managed in exactly the same way. People say that lower skills are sufficient, which means from a company's perspective that even lower paid staff could do the same job. And the great thing is, as a consequence of scalability and ease of scalability, that you really can start very small, exactly with an infrastructure that meets your requirements. And when your business grows, then actually you can grow your infrastructure as you go. And this means for you in the IT organization that you can flexibly align the infrastructure to the business, to the demands of the business. You can demonstrate a great responsiveness towards the business, and due to the built-in high availability, business continuity will be ensured, and at the end of the day, it's even the total cost of ownership that can be lowered. And doesn't this sound great? Many people think that this sounds great, and this could easily lead to the conclusion that hyper-converged is the silver bullet of IT. But the question is it this really? So before answering this question, I want to compare both architectures here on one slide. On the left-hand side, the classical one. On the right-hand side, the hyper-converged architecture approach that we've just discussed. So with classical, we have servers. We have a local area network for the connection between these servers. We have external storage systems. We have a storage area network for the connection and for the data traffic. And this means we have multiple components, and for these multiple components, lifecycle management is needed. And usually, these different components have different life cycles. Moreover, we have to state that two separate networks need to be maintained: a storage network and the local area network. And I'm pretty sure some of you might be saying, well, of course, the local area network can also be used for the data traffic, for the storage traffic. You are absolutely right. This is possible. So from a physical perspective, you are right. But from the logical perspective, this still requires the maintenance of two different networks. Classical architectures, as I said at the very beginning, are hardware-defined. With hyper-converged, we speak of software-defined for compute and for storage resources. What about scalability? For classical, actually, scalability works by adding multiple components, and here primarily separately. That means if today you figure out you are run out of compute resources, then you add maybe servers. If tomorrow you figure out you run out of storage capacity, then you add storage systems, or let's say disks within the storage system. With hyper-converged, scalability always means adding servers. And primarily, this is done linearly. So that means whenever you need more compute performance and you add servers, you automatically will get more storage capacity as well. Of course, there are solutions where this is not mandatory, but on the other hand, the ideal procedure with hyper-converged is to go this linear approach. And what about storage activities? Well, on the classical side, the storage activities are, of course, running in the external storage system. Means they are totally separated from servers. Whereas on the hyper-converged side, actually, servers are, of course, involved in the storage activities because we do not have anything else but server storage is on the servers. And this needs, of course, to be considered when sizing the compute resources. When we started our hyper-converged business some 3 years ago, a rule of thumb that we always used for the sizing was reserve around 10% of your available compute resources for the storage traffic. This was at that time already a very conservative estimation. And meanwhile, of course, the performance of the CPU resources have gone up. So I would say the reserves that you should really spend for the storage traffic are even much less in the meantime. And just talking about the maturity of both architectural approaches, classical, of course, has been in the market for many, many years, I would almost say for decades, whereas hyper-converged entered the market, I think, initially some 5 years ago, but some 3 years ago, actually, it was getting more mainstream. And the question, of course, for you might now be, what do these differences that I just tried to explain, what do these differences mean for you? So basically, the classical architecture could be used for general purposes, no matter whether a workload has to run bare metal, meaning has to run on a physical platform, whether it has to run in a virtual environment or can run in a virtual environment, or if you need an infrastructure that requires multi-hypervisor environment for multiple applications. And the question is now, what do these differences mean for you? So the classical approach can definitely be used for general purposes, meaning it does not matter whether workloads need to run bare metal, that means a physical platform is needed, whether a virtual environment is needed, whether maybe even a multi-hypervisor environment is needed for multiple workloads that require different hypervisors. Here on the right-hand side, actually, we have to say that in most deployments, virtualization is quasi or actually a must. And it also means that typically hyper-converged solutions are based on a single hypervisor. I know there are exceptions, but the typical thing is it's based on one hypervisor technology. With classical, there is a hardware dependence, and primarily when it comes to storage. On the right-hand side, we do not have this hardware dependence, but we have a software dependence instead, a dependence from the software actually that makes all this hyper-converged stuff happen. When it comes to operational complexity, as we said before, this is extremely lowered with hyper-converged, is correspondingly higher with classical. And when it comes to purchase cost, we have to say, well, as we have an external storage here, usually the hardware costs are higher and the software costs are lower, but with hyper-converged, it is vice versa, meaning hardware cost lower, but software cost higher. And what is now cheaper or more expensive, this extremely depends on the use case. There is no general answer that you can give up front. And with regards to the vendors that are going for these approaches, so the classical one actually is covered mainly by well-established vendors. Hyper-converged was invented by newcomers. There are many newcomers out there at the time being, but the established vendors, they have jumped onto this train as well. And what I wanted to bring across with this comparison is actually that there are unique advantages on both sides. Here it is the usage for general purposes. Here it is the by far lower operational complexity. So from our point of view, there are good reasons for the coexistence of the two approaches. And I'm pretty sure that some of you might be wondering, so what does it mean now for a particular use case, for your particular use case? If you want to introduce a new infrastructure, should you go classical? Should you go hyper-converged? And there is no black and white answer. So it will always depend on the use case. And what I can give you here at hand is a couple of aspects that need to be considered. So it's first of all about the workloads. The question is, do these workloads need scale out or scale up? If they need scale out, I would say hyper-converged could be a good direction to go for, because hyper-converged is designed for scale out. It is very easy to add servers, as we said. And especially if compute and storage needs scale in tandem, then hyper-converged is really a great option. And what does it mean, scaling in tandem? For instance, virtual desktop infrastructures, you know. If you assume you have 500 virtual users, and they have more or less a similar user profile, and these individual users have the same demands in terms of compute and storage resources, and now you are adding 100 virtual users more, then it is fairly simple to, let's say, expand the existing infrastructures for the new users. If, on the other hand, a granular expansion on the component level is needed, maybe today you need more compute performance, tomorrow you need more storage capacity, or you need more storage capacity all the time, but not that dramatically further compute performance, then actually the classical approach would be the better way to go. Then it's about expected growth. We heard that growth is excellently supported by hyper-converged, but if there is no growth expected by your infrastructure, then actually you cannot take advantage from it. The next thing is ROBO, which stands for remote offices or branch offices. We have customers that say, we have had so much headache with our robos and the storage area network in these robos, we had to send people from the headquarters all the time to these robos in order to look after it and do some maintenance work. If we replace the storage area network in the robos by a hyper-converged infrastructure, then actually everything can be done very simply from the headquarters, from the data center in the headquarters. So this is another aspect. Then, as I said before, if we are faced with workloads that have to run bare metal, if we have multiple workloads that require a multi-hypervisor environment, then usually hyper-converged is not the recommended option. And then the question is, do the workloads benefit from the built-in data services? If they do, you could say, oh, that's great. I get something for free that I anyway need. But if it is the other way around, if you don't need them, you could say, I pay implicitly for something that I do not use. It's always a matter of consideration. And what we also said before, the unified management of compute and storage resources is a great advantage. But the question is your organization ready for it? You might have existing skills in your organization. You might have storage experts, etc. And maybe there is some resistance from these people if you all of a sudden want to change the paradigm. So, and the question is, do you want to be faced with this resistance and this situation? I cannot answer for you. And then it's about your storage strategy. There are organizations saying, well, whenever I introduce something new into my data center, it will have to run with a certain storage that I decided for 10 years ago. If this is the case, then maybe hyper-converged is not the best recommendation. On the other hand, there are customers saying, oh, there is so much headache every day with the external storage and the storage area network. And for those people, maybe hyper-converged is a good first step into another direction. And then, and this is really a critical point, this is storage capacity. You know, most of the hyper-converged deployments, they are limited by the number of cluster nodes, of server nodes. And of course, every server which is included in such a cluster has a maximum storage capacity. So, and if you multiply now the maximum storage capacity by server times the number of servers, then you will end up with a maximum storage capacity in this hyper-converged solution. And if your storage capacity is higher, then I would say hyper-converged is a no-go. And then another important aspect is software licensing. I think with classical, you are pretty much familiar with the license policies of database vendors and other software providers. But here with hyper-converged, depending on the license policy, you perhaps have to pay licenses for every CPU or every CPU socket or every CPU core where in theory this workload will run. And as in a hyper-converged solution, normally everything is transparent to you. You do not know on which of these sockets or cores or whatever the workload will run. That means you would have to pay license fees for all of them, and then from a commercial perspective, pretty soon hyper-converged would be a no-go, because at the end it will always be a cost comparison on the CapEx side and also on the OpEx side. As I said, there is no black and white answer what the result of this will be. So our recommendation here is to decide per each use case whenever it turns out that the benefits outweigh the drawbacks, I mean the benefits of hyper-converged, then it might be recommended to go for it and otherwise leave it. From hyper-converged to a software-defined data center, it's actually only a minor step, because with hyper-converged, the compute resources and the storage resources, they are already software-defined. The only missing piece is software-defined networking, and if you add this and you add a sort of platform that is able to do policy-driven automation for all the stuff you are faced with, be it provisioning, be it configuration, be it operation. If you add this, then actually you have evolved your infrastructure to a software-defined data center. But don't get me wrong, hyper-converged is not the only way to the software-defined data center. I will show you in a minute that there are also software-defined data center approaches based on a classical architecture. And if you bring all of this together, this virtualized everything approach with the unified management for compute, storage, and networking, then you basically have something that is simple, fast, flexible, and efficient, which is actually the right answer to the challenges of digitalization. And now the question is, no matter whether we are going hyper-converged or not hyper-converged, how to get your infrastructure up and running. And if you do all of this in a do-it-yourself approach, then of course you have to select from a myriad of software and hardware components the right ones for your use case. You have to do the integration of these components, and you have to do a very comprehensive test, because the compatibility of these components will not always be ensured. And only after having done this, you will be able to do the actual deployment and the integration into the production environment. So, and we think there is a better approach compared with the do-it-yourself approach, and this is integrated systems where all these tasks, such as design, component integration, and test, have already been done by a vendor before your project has even started. So your project will only be more or less limited to the on-site deployment and the integration into the production environment. And this basically brings the integrated systems from my company, Fujitsu, in play, which is Fujitsu Integrated System PrimeFlex, which is a pre-configured, pre-integrated, and pre-tested combination of all these data center components: server, storage, network connectivity, and software. And this approach, from our point of view, should help reduce complexity, project time, also the risk that things will not work as expected at the end of the day, will also make the operation easier, meaning increase operational efficiency, and relieve you from some of the pain, which enables you to focus more on the really important things of the business. And just to make one thing very clear, PrimeFlex is not only classical or not only hyper-converged, it includes both approaches. That means Fujitsu has no reason at all to push you into a certain direction because we understand one or the other better. So our approach is really in a kind of co-creation process, and I think this wording was mentioned a couple of times already earlier today, to figure out jointly with you the ideal approach, and then we can select the right offering from this PrimeFlex family. It is an entire family of integrated systems. Some of these integrated systems in standard sizes are even delivered ready to run, meaning pre-installed in the factory. But of course, one size does not fit all. That means sometimes customers have specific requirements, and that's why the second option with our PrimeFlex systems is reference architectures, which can at a certain extent be easily adapted to your specific requirements. And no matter what it is, these systems are based on best practices and experience. And just to mention one thing, Fujitsu was the first company in the world shipping an integrated system. This happened back in 2002, and even a successor of this first shipment is still alive and part of today's PrimeFlex family. These systems are based on own technologies from Fujitsu, for instance, Primergy servers and other stuff from Fujitsu, but of course also a lot of partner technologies, especially on the software side, are involved. And what is also worth mentioning, sorry, now it was my mistake, PrimeFlex is not just boxes, meaning we are not just shipping these boxes and leave you stand alone in the rain. So PrimeFlex is supplemented by flexible services options throughout all phases of the life cycle of such a system, from design via deployment, integration into the production environment, migration services, overall solution support with a single point of contact, and so on. These services are either delivered by Fujitsu or our local partners that we also need in this game. And this slide just gives you an impression what the focus areas of PrimeFlex are. Due to the time constraints, I cannot dig into all of them. I just want to have a closer look at virtualization, and this is exactly the area where the question hyper-converged or classical is very often discussed. And currently there are 5 offerings in the virtualization space here. Maybe at the first glance it is a little bit complex for you to understand the positioning, but I hope this slide will help you. So on the upper half of the slide we do have 4 hyper-converged systems. On the lower half it's actually a classic infrastructure system. Here on the left-hand side, it's those which are based on virtualization technology from VMware. On the right-hand side, it's those that are based on virtualization technology from Microsoft. And what you can guess here, this PrimeFlex V-shape, which is the only classic member, gives you the choice to go either VMware or Microsoft. And these figures here should give you an indication about the maximum scalability. These figures represent the maximum number of nodes, of server nodes, to which these configurations can be expanded. And a special word here on PrimeFlex for VMware Cloud Foundation. This is a fully fledged software-defined data center, including software-defined networking, expandable up to 192 nodes. Okay, good. One thing we should not ignore here, all these virtualization offerings are based on our Primergy servers. And why am I saying this? Our Primergy servers are the absolute world champions for virtualization. It's seen as the most powerful virtualization platform in the world, which is again and again demonstrated in the de facto standard for virtualization performance, which is the VMark benchmark. And I'm showing here the situation from 2012 up to 2017, all these various categories of the benchmark. And whenever you see red, this means Fujitsu has been the world champion in the respective category. And as the headline of this session included the term of SDDC, software-defined data center, I also want to show you here what our SDDC offerings in the PrimeFlex family are. We discussed already PrimeFlex for VMware Cloud Foundation. It is the hyper-converged flavor. And if you want to go for classical, if you are even a supporter of open source or OpenStack, then we can discuss PrimeFlex for OpenStack, where we give you choice with regards to the OpenStack distribution. We collaborate with Red Hat and we collaborate with SUSE. And this brings me already to my summary. So what are the most important takeaways? So I think there is no doubt Hyper-converged is a rising star out there. This is impressively demonstrated by all the figures coming from the analysts. And I think we have also seen that many benefits can be derived from all of this. And it is an excellent springboard to the software-defined data center because there is no need to add so much, just the software-defined networking and this unified management platform. But it is not the only way. Hyper-converged is not the only way. Use cases matter. Some aspects need to be considered. And when you have found out what the right way for you to go is, then integrated systems can help you to reduce complexity, project time, risk, and cost. And with the integrated systems family of my company, Fujitsu, which is PrimeFlex, we give you really choice in terms of classical, in terms of hyper-converged, and we figure out in a sort of co-creation process the ideal solution for you. So if you are wondering if hyper-converged is your way to go in the future, I can just encourage you to have a word with my company, Fujitsu. Thank you very much for your attention.